Hi, I'm Nitya, your tutor at Nityaz Academy. Let's learn kinematics, motion in one dimension together, step by step. Let's describe motion along a straight line. Displacement tells us how far an object moved and in which direction, not just the path length. Velocity is displacement per second, so it carries direction too. Acceleration measures how quickly velocity changes each second. Because all three have direction, we use plus and minus signs to keep track of which way things point. When acceleration is constant, two equations do almost everything. Final velocity equals starting velocity plus acceleration times time. Displacement equals starting velocity times time plus 1/2 acceleration times time squared. A perfect real example is free fall. Ignoring air resistance, gravity gives every object the same downward acceleration of about 9.8 meters per second squared. A car travels at 20 meters per second and brakes with an acceleration of -4 meters per second squared. The minus sign means it slows down. We want the time to stop, so final velocity is 0. Setting 0 equals 20 minus 4 times time gives time equals 5 seconds. The car needs 5 full seconds to come to rest. Now drop a stone from rest off a bridge. Its starting velocity is 0, and gravity gives it 9.8 meters per second squared downward. After 2 seconds, displacement equals 1/2 times 9.8 times 2 squared. That works out to 19.6 meters. So in just 2 seconds, the stone has already fallen nearly 20 meters. Let's wrap up. Motion on a line is captured by position, velocity, and acceleration, and signs tell us direction. When acceleration is constant, the two motion equations predict velocity and position at any moment. Free fall is the classic constant acceleration case. Master these ideas and you can describe almost any straight line motion you'll meet. Great work today. Great work! Keep practicing with Nitya at nityazacademy.com for free lessons, worked examples, and practice.